how time and interest affect money. What we covered so far in the previous 2 lectures. Single payment, F given P, P given F. This for single payment, regardless in which year they are. If you want to find the F, a future value for certain present value, and that present value, it can be in any year rather than 0. It can be in year 1, year 2, year 3, to find the future of it. If it's, for example, in year 3, you want to find the future of it for in year 4. Just one after or 1 year after that period. It's considered as future. Or to find the P giving that future. Again, that P can be in any year. Second, we saw the present worth, P given A, capital recovery, A given P, sinking fund, A given F, and uniform series, F given A. Hope you still remember the 3 conditions for any annuity. We're supposed to have those 3 conditions. First, equal amount, consecutive, i.e. uninterrupted with Waslin, and third one, end of period. Those 3 have to be together. Today, inshallah, we'll see the other section, which is about arithmetic gradient, P given G and A given G. And of course, when we say P, it means we can find also F given G. Arithmetic gradient. We'll see what is that arithmetic, why we convert that F given P, or let's say here P given F or P given A, why we put that G, because of the word gradient. But coming to the next lecture, which we are going to cover geometric gradient. Notice we don't have a standard or a factor for it, like what we have for those in here. We'll see it inshallah next lecture. But today, let's concentrate on the arithmetic gradient. And let's see what is that arithmetic gradient. So first, we need to identify or to define what is that arithmetic gradient, how to work with it, how to solve it. Let's start with this section and to see the definition of it. So arithmetic gradient factors. P giving G, A giving G. Not only this, we can see F given G. Even if you don't have a formula for it, we'll see how to calculate it. But first, let us identify and find and define that arithmetic gradient. How many calculations we're supposed to do? Arithmetic gradient is a cash flow series. Up to here, cash flow series. It can be annuity. This is similar to annuity. But what about this series? How we are going to distinguish this type of series from annuity? I mean, arithmetic gradient from annuity. Remember, in annuity we said a constant amount, uniform, same or equal amount of money in every period. But in here, with the arithmetic gradient, it's either increasing or decreasing. So it can go up over that cash flow, or it can go down. So increasing, decreasing, regardless if they are upward or downward. It's taken downward. This is increasing. And that one, the other one, from the same one here, this is decreasing. Increasing, decreasing. The only thing different here, that one to put positive for it, and here to put negative. Why? Because this is upward and this is downward. For increasing, it will be positive. So positive multiplied by positive is positive. For downward, for decreasing with the upward, that one negative. So negative multiplied by positive, it will be negative. Come to the other side, downward, negative. and that one increasing positive. So negative multiplied by positive, it will be negative. And for it decreasing, negative multiplied by negative, it will be positive. Some of you will say, what is this? We don't know what are you talking about? Again, let us see it from, or to see step by step. It says here again, it's an arithmetic gradient, increasing or decreasing. At what? By what? By a constant amount. And that's why, by the way, that's why we put a straight line. So it's increasing or decreasing by a constant amount. What is that constant amount? That's the gradient. That's the capital G. How to calculate it, we'll see it now. So the cash flow, whether income or payment, when we said income upward or payment downward, and income or payment, any of this or any of them will have either increasing or decreasing of that cash flows by a constant amount, which we are going to call it later on, or we are calling this as an arithmetic gradient. So that cash flow changes by the same arithmetic amount, constant amount. In year one, we have, for example, $1,000. That $1,000 was going to increase by 100. So year two, it will be 1,100. Year three, it will be 1,200. Year four, 1,300, 1,400, 500, 600. So it's increasing by 100 over the previous year. That's why we call it same arithmetic amount each period. Each period. And that's known as a gradient. Let's see an example. If an engineer predicts that the cost of maintaining a machine, so he has a cost, he put in his mind that in year one, we're going to pay, for example, $1,000 as a cost for maintenance. Always in maintenance is downward. So the cost of maintaining a machine in the first year, it was $1,000. It's just an example here. This in year one was $1,000. So in year two, that is going to increase. See what's written here. A machine will increase by $500 per year. So the first increment will be in year two, $1,500. In year three, will be $2,000. Year four, $2,500, and so forth, till the end of its life, until the machine is retired. The retirement here, salvage, until the salvaging of that machine, لحد ما يحولونها للتقاعد, or to sell that machine, the life of it, the useful life of that machine. That's the same as salvage. Salvage. That's the word we are going to see it a lot today, a little bit, and common lectures. Notice here, the first year we have a constant amount, or that amount cash flow. It's like an annuity. We have that 1,000 every year, but that 1,000 is going to increase next year, i.e. starting from year two. Starting from year two is going to increase by how much? By $500. That one again is going to increase by $500 over what? Over the previous year. So 500 plus 500. In here, third year, 500, or fourth year, 500 plus 500 plus 500. That's why we're going to add 1,500 over the initial amount. So what we are going to have, we are going to have that annuity as a rectangle, area of it as a rectangle, like a previous annuity that what we studied before. And here we have that triangle, which is the gradient. So like having two calculation. We'll come to that. So a gradient series is involved, and the amount of the gradient is $500. Did the capital G. That $500 is the capital G. Remember the factor to calculate for P given A. If you want to calculate present value for a given annuity. So how to find the present worth P for the following example. For example, here we have annuity, let's say like what we put earlier, $1,000. We have that I 9%. Ln here, let's say 15. So to find that P now, again, just to remind you, we don't have to show all those arrows, just to connect between the first and last one. Here we are starting the first annuity, the first cash flow of that annuity in year 1. We can start it at in year 2 or year 3 or year 4, whatever year. So the P for it will be 1 to the left of the first cash flow. 1 to the left of the first cash flow of that annuity, of that first cash flow of that annuity. Now to find the P, since we have it at time 0, 1 to the left of the first cash flow, so P here will equal to the annuity direct substitution, 1,000. Open the bracket now. What we want to find? We want to find that P, giving what? Giving this annuity here, the interest 9%, and N, how much is it? Not that N. How much is that N? It will be 15, which is the last cash flow or the last period of that cash flow of that annuity, minus 1 to the left of the first cash flow of that annuity. 1 to the left. 1 to the left here, which is 0. So we have 15 periods. 15 periods. And from here we can calculate that present worth or present value for this annuity. Now, if for the same annuity, so what we are going to do now? We have an increase or increment. But what if the annuity cash flows increased or decreased? We cannot have both of them in the same cash flow, either increasing or decreasing in the same cash flow. So what if that annuity cash flows increased or decreased with the same arithmetic amount each period? Like what we have in here. Did the annuity, like what we did in the previous example. Did the same what we did in the previous example here. What if that one, we have another, or we have this increasing or decreasing? In the second year, over the first cash flow is going to increase by that amount. And here is going to increase by 2 amounts. So G plus G, i.e. 2G, 3G in here, N minus 2G, and here last one, N minus 1G. How to calculate now the present value for that? Notice what we have at the beginning. Notice in here what we have 0 increment. The first increment, the first one, 1G, will be in the second cash flow over that annuity. So 1G, and this is 2 here. 2G, this is 3 in here. 4G, this is 3G in here. So that's 15%. which is n, i.e. we have n minus 1 g in here, talking only about this part. And of course, every one of them need to be added over that amount, which is the annuity. So how many calculations we have? If I ask any one of you to do the calculation, for example, what you know the area, we have this length. Let's say here 15, let's say here 5, that one, let's say 10. Can we find the area under the curve? The easiest way, if you don't know the formulas, the easiest way, if you plot this, so what we are going to have in here, at that part, rectangle, so we can calculate the area under the curve for that rectangle. And in the other part in here, we have a triangle. We can calculate the area for that triangle. If you want to get the full area, just add the first area in here plus second area in there, so we can have the full area or the total area for that shape. Come to that, did the same idea what we are going to do in here. So we're going to have two calculations. And by the way, did the only cash flows, the only series that got two calculations, whether it start from year 1 or start from year 3 or whatever year, is going to have two calculations, one for the base annuity, i.e. for that rectangle, and the second one for the triangle, i.e. for that arithmetic gradient. So what we have in that part, we call it base annuity. So this is constant. A constant. Do we have an increment, increasing or decreasing? Someone will say, okay, what about if it's decreasing? Are we going to go for this one here? No, still we're going to use the same annuity in there. See that one? And it's decreasing. What will happen? This area here now, if we said, okay, what we are having there is this rectangle. We have all that rectangle, but this area is not with us. So what to do? After finding, you can see that triangle is the same as this triangle in here. So after finding for that rectangle, just subtract this part. Subtracting in here will give you that area. That's why always to take annuity from the first cash flow of that series. Always to do this in our calculation. If you want to find P, we're going to have two calculations. P given A, I'm just writing the factor here, not the standard notation, plus P given G. That part, always to use the first cash flow, whether it's increasing or decreasing. We'll use only the first cash flow, regardless of how much we have till the end. Use the first one. Second, notice what we have. Always with the first cash flow, to find the P, it's 1 to the left. 1 to the left of the first cash flow. أبعدها مرة ثانية regardless of what is this value, because we can have remove all those. You can have the 0 in there. Which means what? 1 to the left. The first cash flow here for that series or for that annuity is at year 4. To find it, 1 to the left, that P. So we are going to find P at year 3. Always one to the left of the first cash flow. But that's not our P. Our P need to be at time 0. So what to do? Later on, after finding that value, it will be our future. So we can shift it to time 0 normally, like what we did before, just by finding P given F, the interest, N. How much is that N? 3 minus 0, so it will be over 3 years. If that's 15, for example. So how many cash flows we have inside here? It will be 15 minus that value or year where we have going to calculate a P for it. 1 to the left of the first cash flow, so it will be 15 minus 3, i.e. 12 periods. 12 periods. You can count them in your hand, you're using your fingers to see how many cash flows we have inside that series. 4, 5, 6, 7, and up to 15. You will find later on we are going to have 12 payments. Why? Because the first one is inclusive. Let's see them now, one by one. But at the beginning, let's just recall what or to summarize what we said earlier about the two calculations. Two components, P given A plus P given G. Always to have this when we have arithmetic gradient, increasing or decreasing. The base annuity components to find P giving A, the first cash flow in that arithmetic gradient at the value for this annuity. Diamond first cash flow at the value of this annuity. The gradient component, find P given G. We have the formula. We have the standard notation for the first part. Want to see the formula or the standard notation for the second part, the second component. Our objective here now is to concentrate on the second part. We know now it's containing two components, two calculations, one for annuity and the second one for the gradient. We're going to concentrate on the second one because we know the formula and the standard notation for the first one. So the objective now is to find a closed form expression for the present world of an arithmetic gradient, i.e. for the second part. For the second part, it doesn't mean that we're going to do calculation only for G. No. Later on, we need to add both of them, A and the G. P given A and P given G. Requires two separate calculations. We'll do now only for P given G. Why? Because we already done for P given A, and we saw how to find the present value for the annuity. Consider this now. The example. The first cash flow is 1,500. First cash flow 1,500. Just draw a line. You will find it. Even if you hide all those, you're going to hide all those. What you're going to have? Just an annuity. Just an annuity. How much is that annuity? With the first cash flow, so we have A equal to 1,500. The second part. How to tell that what we are having is an arithmetic gradient? Need to check before doing this. Need to check all the cash flows. That one increased over the first one by 50. And here increase over that one by 50. That one increase over that one by 50. So what we are having? A constant amount increased by a constant amount. It's downward. This downward. If you want to find the present value, look for the first cash flow at that series. It's at year 1. So P will be 1 to the left of the first one. To find the P will equal to, take the annuity, 1,500. I'm going to do this now. Why? Because with that we have two calculations. P given A let's say I equal to 10%. We have an N 15, 10%, 15. This for the first part of that one, which is the annuity. Let's add the second part now. It is increasing. So since it's increasing, we are adding plus. Plus what? How much? That G. The first one, second one, third one, and every year it's increasing by 50. Increasing by 50. P giving G 10%, 15. Why we put 15? 15 minus 1 to the left, i.e. that's 0, so it will be 15 period. Notice in here, 10%, 15. The same one, 10%, 15, exactly need to be the same. You cannot change it by yourself. You cannot change it for single or for one cash flows or for one series. You cannot change by yourself. Number of years here will be the same as number of years or number of periods in there. Though the first increment, it's in year 2. But we'll consider the first one. We'll put it as 0G, 0 increment. 1G, 2G, 3G, up to the last one, which is 14G. In here, we're going to have 14G, i.e. n minus 1G. Why we said 1? Because the first one appears at year 1. Later on, we're going to have another thing. If we have a mix of cash flows, upward and downward, so we need to consider the sign. How to consider that sign? Since this is downward, so we'll put negative in there. A negative is a common for both of them. Negative is common for both of them. Anyone will write directly negative 1,500, P giving A to show that. And here increasing, if you put directly just plus, adding, this is wrong. Why? Because negative multiplied by positive, we're going to have negative. Downward, increasing. This is downward and increasing. Downward, negative, increasing, positive. So negative multiplied by positive, it will be negative. Downward, decreasing, i.e. downward, negative. Decreasing, negative. So what we're going to put here, positive. If it's downward and decreasing. Hope that's clear. So the diagram of an arithmetic gradient series with a base amount. What is that base amount? Which is started at year 1 with 1,500 as the first cash flow of the annuity. And the gradient of 50. So we have two calculations. One for the annuity and the second one for the gradient, arithmetic gradient. The origin of the series is at the end of the first period. End of the first period. Now an arithmetic gradient factor. How to write that factors? We have P given A plus P given G. We're going to leave for a while the base annuity. For a while, we're going to leave the base annuity. Why? Because we already know how to calculate it. FLG greater than 0, the series is referred to as an increasing gradient series. If it's increasing or G greater than 0 positive, so this is increasing. If you're going to put G negative, i.e. less than 0, this is decreasing. When I said that, it's between the two brackets. One for P given A and the other one for P given G. If you're going to put positive in here, it means this is increasing. If you're going to put it negative, this is decreasing. The present worth point is always 1 to the left period of what? Of the first cash flow of the base annuity. one time period to the left of the first cash flow in the series, or if you're going to consider it with the first gradient, the first increment, so it will be 2 to the left, 2 periods to the left of the first gradient cash flow, first gradient cash flow. See it in here now. Focus only on the gradient component. We know how to work with the annuity. It doesn't mean that we don't have two calculations. No, still we're going to do the two calculations, but just to find the formulas and to show the factors for that gradient. Formulas and the factor for that gradient. We'll leave the base annuity for a while. Then, once we come to examples later on, we're going to see, or we're going to retain them back. But for now, let's only work with that triangle. Note the first one and the first, or with the first cash flow of that annuity, it's 0G, 0G. So at time 1, period 1 is 0G. Period 2, it's 1G. That's why they said 2 to the left to find the P, 2 to the left of the first annuity or the first arithmetic gradient. The last one, N minus 1G. Why we said N minus 1? Why 1 here? Because we start 0G at time period 1. What about if we start at period 3? So that one, if you start in here, that one will be N minus 3. We'll see that once we come to it. Now calculating the cash flow in year N. Base amount plus N minus 1G. N minus 1G. Always to have that. Let's see the example. The base amount is 80,000 and the total revenue increases in year 9, 1,000 or 120 or 200,000. Increase in 9 years. So here, that one we have it 20 or 200,000. So how much is the increases? 200,000 in last period minus 80,000 in the first period. So the increase is 120,000. 120,000. How many increments we have? Increase in 9 years. So how many increments we have? Actually, we have 8 increments. 8 increments. And so for what I said earlier, it always will be N minus 1. N minus 1. So we have 8 increments in here. 8 minus 1. Oh, sorry, 9 minus 1 will be 8. So if you divide 120,000 by 8, it will give you a capital G. Capital G, how much is the arithmetic gradient? How much is going to increase per year? $15,000 per year. The present world factor, P given G. P given G. Now, what is important from us here to see the formula that used for that capital G. The present world factor, P given G, can be expressed in the following. The standard notation for it, the P equal to G, whether it's increasing or decreasing, its sign in front of it will tell us if it's positive, it's increasing. If it's negative, it is decreasing. P given G, this is standard. You cannot change it by yourself. Always to leave it as it is, whether it's P1, P2, P3, whatever, it will be the same. Just P given G. The percentage here and the N, that will be the same as the base annuity. The factor or the formula. Factor formula. If you want to calculate only this part inside here, so use that one. We'll give you this. Why? Because this G is the same as that one. So we need to substitute directly for this G here, Li N. Li, if it is 9%, so we need to substitute there 0.09. And here, 0.09 multiplied by N, 0.09 squared, 1 plus 0.09 to power N. Remember, the present world point of any linear gradient is 2 periods to the left of the first G, or 1 period to the left of 0G cash flow. Let's see the conversion. We want to convert the arithmetic gradient into a single payment P, single payment. Now here we are considering only the gradient, only the gradient. Of course, we have the annuity. The annuity was somewhere in here. That annuity in there. But we want to see just for the gradient now. In a while, we'll see it for both of them. Downward, increasing. Downward, negative, increasing, positive. 2 to the left. 2 to the left of the first gradient. We have here 0G. Anything multiplied by 0 is 0. That's why we're not going to consider it. Notice if you load that line, we're going to have it here with the first here at this point here. So that is the annuity, the base annuity, and what we have in here is the gradient to find this P. Same thing with the, if you want to convert now that gradient, and instead of finding a P, want to convert into annuity. What to do with it? The same thing, Finding 2 to the left of the first gradient. What we're going to get? That P, 2 to the left of the first gradient. What about if we want to convert into annuity? That annuity will not be from year 2, no, it will be from year 1. The annuity will be from year 1. Exactly similar to the other calculation. Exactly similar to the other calculation. Why? Because what we have here, we have a 0G in the first period in here. That's why the first period is inclusive in our calculation for the gradient, for the conversion of that gradient. Not from the first G, no, from the 0G. To convert an arithmetic gradient G without the base amount, Why not to convert the base amount to A? Because already that's an annuity. If you're going to find A given A for the same annuity from year 1 till year 15, for example, already we have it in annuity. So converting A given A will give you 1, i.e. the same number. That if it is in the same period from year 1 up to year N, or let's say year 15. To convert an arithmetic gradient G without the base amount for N years without an equivalent uniform, or into an equivalent uniform series of A value. That to give us what now? For A giving G. How to find it? We have a G. What you need is to convert A given P, multiplied by A given P. So G here, which is P given G, if you multiply by A given P. Why to multiply by A given P? Because already in this stage here, with that one, what we are going to do, we're going to convert this into single amount P. So to find the P for that gradient, or to find the annuity for that gradient, just multiply P, A given P, I% N. Where to get this? From that calculation. So if we have the formula for P given G, Don't say, but we don't have the formula for A given or for A given G. It's not a problem. Find that P first, convert it into a single amount, then convert it again into annuity to find the annuity for it, for that P. This now to find the formula for it. A will equal to G, the factor now for A giving G, which is what we have inside here. This factor, we asked you to find it, did the value for it. Did the value for it. 1 divided by I minus n divided by 1 plus I to power n minus 1. Now, that conversion, like what we showed in the plot earlier, converted now. Notice we're going to start from year 1 y back to, because what we have here is 0G. It's inclusive in our calculation. I'm repeating this again and again because 100% some of you will do it wrongly. Make sure to get what I'm saying now. 0G is inclusive in our calculation of that gradient. Whenever you want to find the A given G, we have an increment here. And by the way, we have two calculations. We have another base amount already hidden in there. We're going to use it later on. So we're going to find for this G, for this gradient, you can find an annuity for it, then add that base annuity directly. How much A we have here, just add it directly to that one. The value in here, say for example, this it was 1,000 in the previous example, just add it directly over that one will give you the total annuity of that gradient. F giving G. Back to what we have in here. Always the future value with the last cash flow. Whether it's annuity, whether it's a gradient, arithmetic or geometric, always with the last cash flow. ما بأي واحد. I don't want any one of you later on to add one period to find the F for it. No. The F always will be with the last cash flow. If you want to find the F, it will be in here. With the last gradient, with the last cash flow of that series. But how to find it? What to find the F giving G factor. So convert an arithmetic gradient G without the base amount. Why? Because we know how to calculate in any of those, either for to find the P or to find the A or to find the F, we need to add for the base annuity. We need to add the second factor, the second component of the base annuity. A to find the P for the A, given A, or to find the F giving that A, in addition, of course, to the F given G, or to add directly the A for that base annuity over the A giving G. Now here, it says without base annuity amount. It doesn't mean that we're not going to add for the base amount, just to find or to show the factor here and to show the formula. Later on, some of you, 100%, I'm telling this because every semester we have the same mistake from certain or number of students. They said it's written there not to add or not to work with the base amount. No, with the arithmetic gradient, always to have two components, one for G and one for A. Whether to find the P for it, whether to find the A, whether to find the F, two components. So the future worth factor for F giving G can be expressed in the following form. F equal to G, F given G, I percent N. Sometimes we are not giving this, especially if it is a closed book. assessment, test, or exam. It doesn't matter. You have for A, first P giving G, you have that. If you multiply this by F giving P, and we have a factor in here, this will give you that part. Just canceling those two together, so it's F giving G. A, after finding the present worth for that gradient, you can just shift it to the future by multiplying by that F given P. What is the formula for that F given P? F equal to P1 plus I to power N. Just multiply by this part. What is that P? Which you're going to calculate it from there. And that's how we derive this formula. We multiply P giving G by F giving P, so we got that formula. This is an example now for finding for a future worth factor. Need you to read it now. First to plot the cash flow diagram for it. Then we'll work with standard notation, and after that, finding the answer from the formulas or by using your calculator. Read the question carefully. See all the data. We'll read it with you now. Suppose that you make a series of annual deposits. Someone directly will say, okay, what we have here is an annuity. Let's continue reading. Into a bank account that pays 10% interest. So what we have here, I equal to 10%. The initial deposit at the end of the first year. Initial deposit at the end of the first year. It was 1,200. So in year one, you just plot that one. This is the first year here. A deposit, it means downward. $1,200. Again, someone will say directly, what we have here is an annuity series of annual deposit. Just read carefully. It says the initial deposit at the end of the first year is 1,200. Now, what's it saying in the second part? The deposit amounts decline. Decrease. Is decreasing now. By how much? $200. What is this $200? This amount, which they put it in here, they are not going to continue putting that 1,200. It's going to decline by $200 in each of the next 4 years. Next 4 years. Remove that from here. So we have in year 2, 3, 4, 5. Why it says next 4 years? So this is the first year, or the first 1G in here, second G in here, third G in here, and then the fourth G is going to decline by how much? G of negative $200. Negative $200. How much? How much? We have the I in here now, 10%. It says here now, how much would you have immediately after the fifth deposit, i.e., talking about how much to have in here, that F. Need to do that calculation. Notice now, what do we have? We have two components. Why? Because what we have It's a constant amount of $200. Constant amount of $200 is the arithmetic gradient. So to find the F, we have two calculations. The first one for the base annuity. That base annuity always starting from where? Starting from the first cash flow. First cash flow. 1,200. To find what? We want to find the F, giving what? Giving annuity. 10%. How much is N here? How much is N? And by the way, there is no participation at all in this section. This is for the third time now. No participation at all. And honestly, at the end of the semester, if you need any mark, I'm not going to give.
5 minus 0.
5.
I don't know who to it now. يعني كلكم تتكلموا مرة واحدة أو ما حد يتكلم. يس صادق.
5.
Actually, it's 5 minus 1 to the left. So it's 5 periods. It's decreasing. Now we want to add for that G, upward or downward, is downward, decreasing. Who can tell me now what will be the factor in here?
Minus 200.
Minus 200. Yes, Hussein. Say minus 200 is not enough. What to do with it?
G قوس.
حسين اعطيكم الجمله كامله، لا تعطيني بالهاي. اعطني جمله كامله. If it's minus 200 directly, I'm going to give you 0 for that.
G given A. 10%. G given F given A. F given G.
اي واحده اخذها الحين.
Find F given G.
F giving G.
10%.
Yes. 10%.
5 years.
Why you put 5 years? ليش 5?
لازم نفس
Same as this one here. Thank you, Hussein. Now, this is downward. We can put a negative sign outside there if we have a mix of cash flows. So if you are going to distribute this, so to be negative 1,200 F given A, 10% 5, negative multiplied by negative plus 200 F given G, 10% 5. احنا خدنا common factor for this calculation in here. Now, use your calculator to find the answer. Use your calculator to find the answer. What to use? We can put them directly in the calculator for all those cash flows in here. In cash. تروحون على الكاش. الكاش editor. The first amount or the first entry, second entry, third, fourth, fifth, sixth, seventh entry. The first entry, how much is it? لا حد يكتب لي كتابة. تكلموا. I cannot jump from chat. Yes, Ahmed.
10%.
لا اوكي دشينا على الاديتور الحين. الفيرست entry in the editor how much will be?
Zero.
Why 0? Because what we have in here, nothing, just 0. Second entry.
1200.
That's right. Then we want to continue till which year?
1000.
Year 5. Year 5, i.e. to stop at the 7th entry without putting anything. So it will be 1000 here. It's decreasing now by 200 in each year.
800, 600, 400.
In year 7 or an entry 7. Are you going to put anything in here?
No.
No.
Nothing. Why? Because if you count them now, how many cash flows? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The same as what we have in there. So after doing this, now you can find the future value. Find the future value. How much is it? شباب.
طلع عليه 12994 اس دولار.
No, wrong. There is something wrong.
5115.
115.92.
Okay. But before writing anything,
Dollar.
dollar sign. 5115.92. 2 decimal, 9 sign, dollar sign, and that amount. So standard cash flow diagram, standard notation, final answer. That's how we're to get marks for any problem. Cash flow diagram, standard notation, and final answer. Anything in between, if you're going to do calculations and I don't know what, that's only for you. No one will see it. What are going to see? Those are 3 things. Cash flow diagram, standard notation, final answer. But sometimes some of the students will do calculation for this part separately and that part separately, then to add them, for sure. Some of you, what we are going to do, using the compound interest. If you put positive here, it's going to give you negative. Always take whatever signs you put. Don't let the calculator controls you. So I'm talking about a compound. But for the cash, no. Take exactly what sign will be given to you. That's all for today. Now, let's see the example that I told you about at the beginning of the chapter or last week, which is about this one. It's very important to understand it and to solve such a problem. It's very important, very important. Why? Because later on, our problems will be a mixture of cash flows, annuity, gradient, which is geometric and arithmetic, single cash flows, shifted, not starting from year 1, no, it can start in any other years. Let's work in here now. Always start with the easiest thing. What is the easiest thing for us is to find for what's required from us here to find the P at time 0. Required from us here to find the P at time 0. First, we'll start with single payment. We'll start with single payments. We have one payment at year 5. This when we put it at the top there, we are talking about this year here, year 5, because we cannot put it from underneath that gradient. Second one, another 1,200, it's year 9. We have third one, 950 at year 13. Those two upward, and here is downward. We have that salvage value. Salvage value at year 15. All of them, by the way, they are future to that present at time 0. So all of them need to be shifted to time 0. Now, to write a standard notation, to consider the cash flows, the sign of it, upward or downward. Now let's do it. Not to confuse, we want to find the summation later on for all the P's that we are going to find. The first one for P 1,200, i.e. talk about that one, will equal to what? Now, who want to participate on this? Who want to participate and to solve with me this question? I'm revising with you now for the quiz, the coming quiz. Ali Jamil Tala. Yes, who want to do it? No one. Okay. So negative 1,200 to find P giving F. Li here. Li 8%. Number of years. We're at year 5. Want to move it to year 1. Sorry, to year 0. So this is over 5 years. Find the answer for that. Has to be negative. Has to be negative. Then for the second one, 1,200. Negative 1,200. Be given F. 8%. How many years? 9 minus 0. So 9 years. Again, find the answer for that, and it has to be, sorry, it's not negative, it's upward. طبعا ولا واحد. This upward, it has to be positive. Third one. Third one. I'm repeating again and again, participation, it means bonus. Bonus, it means shifting from grade to grade.
بنطلع 50.
ما ادري مين تكلم ايش صار. سوري.
ال B950.
احنا بس مخلين الارقام هاي عشان بس to know what we are working with. You don't have to show that numbers. يعني مو مشكلة ان تحطون الارقام ولا لا. You can say P1, P2, P3 and so forth. Yes, that's equal to what?
Minus 950.
Minus, why? This downward.
B given F 8% and 13.
13. The answer here, it will be negative. So the first one is positive, this is positive, so the answer has to be a positive sign. The calculator will give you that in negative. No, you need to put it positive. Then still it's upward. Fourth one. Noura.
Dr. Mark.
Yes, tell me about the fourth one, which we have it in here, 6,800.
ناخذ 6,080 positive.
Positive, 6,800.
P given F 8%, 15.
15.
And the
And the
answer will
answer
be
here,
positive.
it has to be in positive sign. Now we've done with just a single payments. What else we have? We have the annuity. We have an annuity, which is that one. It's starting from which year? Starting from year 8. So if you want to say it, if you want to find a P for it, where it will be?
7.
One to the left, i.e. year 7. Who said that?
Me, Doctor.
You want to continue answering it? To find the present value for that?
I don't know how to find it.
For an annuity. Just find for an annuity, normal annuity.
So it's A equal.
Want to find the P, not A. How much annuity we have? This is our annuity. It's upward.
It's 1,000. B given A 8% and 15. Okay, 15 minus 7.
Which is 8.
Yeah.
15 minus 7. والله أنا متخربط أنا ما صح ولا غلط اللي سويته. Just count how many cash flows we have. 1, 2, 3, 4, 5, 6, 7, 8 cash flows inside that annuity. هذا the number of cash flows in that annuity. But what we found now, what we found at the present at time 7. This being here, but actually it has to be where? At time 0. Which means what? What we need to do with that? This is now future value at year 7. We need to shift it to year 0. لأن هاي في النهاية بيطلع لي value. هذا في النهاية بتكون عندي أرقام. هذه الأرقام موجودة على السنة السابعة. In year 7. So what to do with it?
You get the P given F.
So to multiply it by P given F, yes.
I have the N equals 8%, 7.
So I 8% will N 7. Why 7? 7 minus 0, so it will be 7. Now if you add those together, L 8 here plus that 7, how many years? 15, which is the same number we have here. That's what we call shifted series. Shifted series. And by the way, it has to be at the end. The answer has to be positive. Why? Because that series is upward. That series is upward. I'll leave that with you now to work with the gradient. That's what we have in here. Upward and downward. See what to do with it. Find the answer for those P's 1,200, 1,200, 950, 6,800, and for that annuity of 1,000, all of them at time 0. Next lecture, inshallah, will work with those two gradient, arithmetic gradient, and this geometric gradient. Any question?
دكتور.
دكتور عندي سؤال في الأولى. في الأولى وين نحط الجي؟
نفس ما سوينا من شوي، ما في مكان حق الجي. There's no place for a G in your calculator. That's why you need to write each cash flow or to use the formula. If you have a longer number of cash flows, so it's better to use the formula for that calculation.
تمام شكرا.
تمام.
دكتور
يس ابراهيم.
الاختبار الساعة 6 دكتور، لا لو تغير.
ابراهيم توني بغيت اتكلم عن الاختبار. اوكي. لا عندك سؤال عن اللي سويناه اليوم؟ لان ابغى حق سالفه الكويز.
لا اوكي كل شيء واضح.
Excuse me, doctor.
Yes, Taha.
Doctor, the formulas, the equations will be given, or we have to by heart?
No, the formula will be with you. If it's an online, so you have the formulas. But if it is another test, already I've said which formula will be given to you and which formula you need to extract it from others.
Okay.
Like for example, F given G, that formula will not be given to you, but you are going to have A given G, P given F, P given G. Those formulas will be given to you. Okay guys, بس عشان يلحق ابراهيم الحين. Who's from chemical here?
I'm from chemical process control.
You are instrumentation or chemical, Taha?
Instrumentation.
No, instrumentation is different. In chemical, they have one course now. Some of the students, they are taking that course. Is any one of you, do any one of you has a lecture at 6 o'clock? Or let me rephrase my question. Do you have any problem with the timing that we put for the quizzes and assessment? Do you have any problem with that? Yes or no?
No problem.
Then I have not received any comment from any one of you. So what we said that no problem with all of you. Some of the students, unfortunately, once we start or once we announce for the quiz yesterday, just yesterday night or yesterday, I don't know at what time, with Dr. Badr in Dr. Badr's section, they said they have a class at that time at 6 o'clock, finishing at 7. So what we're going to do you have any problem if we we're not sure yet, we're not going to keep the same time, but if we are to postpone it 1 hour to start the quiz at 7 o'clock, do you have any problem with it?
No, Doctor.
No problem.
That's good. So we'll see with them. If no problem with all of you, that's good, Layla. So we're going to, inshallah, if there is any change on timing, we're going to inform you. Still, we have one lecture on Wednesday, but to make sure that you don't have problem with the timing only from the beginning here. And inshallah, before the coming lecture, we'll announce exactly which time will be the quiz. So we are done for today. Okay, guys, we are done. If there is no question, but please do practice. Please do practice. Yes, صادق.
دكتور محاضرة اليوم راح تكون معانا في الكويز.
لا. Already I told you it will be up to the annuity inclusive, but the arithmetic not. يعني لآخر محاضرة اللي خدناها الأسبوع اللي طاف. يعني chapter 1 و chapter 2 up to last week.
تمام دكتور.
يعني حتى الشيفتنج ما بكون وياكم، اللي قاعد نسويه هنا ان هاي الشيفت وهذه بعد ما بكون وياكم. اوكي علم. خليكم الحين. نشوفكم ان شاء الله المحاضرة الجاية. السلام عليكم. علي مكي and طه, you can leave now.
نعم.
خلصت علي. علي بس تقدر تطلع.
اوكي.